So we will go ahead and get started. This section, which is 8.1, is going to talk about different characteristics of polynomial functions. And the first characteristic that we're going to talk about is what affects the end behavior, or what makes the end behavior of a polynomial function do what it does. And so what I mean by that is when you put something in y equals and graph it, there are certain things that are going to make the end, and it's called end behavior, the ends of the graph do certain things. Like, what does an x squared graph look like? Well, it looks like this. And the reason I have this little blank spot on all of these is because we're just talking about the very ends of the graph. Different things can be happening in the middle of whatever the graph is. Okay, but we're just going to talk today about what's going to affect the ends of the graph, whether or not they will both be going up or both be going down, or whether or not it starts down here and travels up to the right side, or whether it starts up on the left and travels down to the right. So what's going to make that happen is its degree. And what I mean by degree is what is the highest exponent of the polynomial function. Okay? If the highest exponent is even, like an x squared graph, your end behavior are going to be the same, which means either both up or both down. Okay? And what makes one go up and one go down? Whether that term is positive or negative. So this kind of end behavior would mean that your degree is even, or the highest exponent is even, like 2, 4, 6, 8, 10. That's what your highest exponent is. It's even. If they're both up, that means the term is positive. And once we see all these written out, this will start making more sense. This would also come from an even function, right? A function that has the highest exponent is even. This can also be an x squared looking graph, right? What made it go upside down? If the term is negative. So again, this would also have an even highest exponent. It's just that that term would be negative. So that's what would make that kind of end behavior. These down here are both if the leading or the highest exponent is an odd number, like 1, 3, 5, 7, 9. Any odd number is going to make your end behavior be 1 up, 1 down. This one, if you start down but you travel up from the left to the right, that is because the highest exponent's term would be positive. This one that travels down throughout the graph, or from the left side to the right side, is because it would have an odd highest exponent, and that term would be negative. That is what makes these end behaviors be what they are. So let's look at some of these. I'm going to leave that chart up there while we go through some of these problems. Let's look at number 1. It says f of x equals negative square root of 5 x to the third plus 2x squared minus 5x plus 2. And it's a multiple choice kind of problem, and it just wants to know what is the end of this going to look like, the end's going to look like if you put that in your y equals and graphed it. Well, like I was talking about, what makes that happen is you go through and you find the term that has the highest exponent, which would be this one. You look for 2 things. You look to see whether the exponent is even or odd, and whether the term is positive or negative. And then you just match it with this. So let's see, its highest exponent is a 3, which is an odd number. And the term, it doesn't even matter whether it's some crazy term like this, it's just that its sign is negative, which means it matches this in behavior, the odd negative. And again, these are all multiple choice, and so you're going to have 4 choices. You're going to have all these in behaviors out there. It's just that you would choose this B because it's odd and negative. It starts up but goes down from the left to the right. So again, you're just looking for the term that has the highest exponent, writing if the exponent is even or odd, and then writing if the term is positive or negative. So this is what we're going to do on the first 4 problems. All right, number 2, the function is p of x equals negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 7. So again, just go find and circle your highest exponent's term, the whole term. So there's what I'm looking at. That has the highest exponent. This time the exponent is even and the term is negative, which means the end behavior is both ends are going to be pointing down. So again, even negative looks like this. Both ends going down. All right, number 3. So this one is f of x equals negative 4.7 x to the 4th plus x to the 6th plus 0.1 x to the 7th. Okay, on the first 2 problems, my highest exponent was actually on the first term. So you're not always looking for the first term, you're looking for the term with the highest exponent, which would actually be this term, right? There's your highest exponent. And then you match it. So that's an odd exponent. And the term is positive. So again, odd and positive, it starts down, but it goes up from the left side to the right side. So that's what odd positive in behavior looks like, which looks like that C, right? It starts at the bottom, but then from the left to the right, it goes up. And the last one like this, number 4. F of x equals 9 plus 1/9 x to the 4th minus 1/2 x to the 3rd. So finding the term that has the highest exponent, which is the middle term on this one. And then again, you just look at the exponent. Since it's an even number, it's going to have an even end behavior. And it is positive. The term is positive. So even end behavior that has a positive coefficient is going to both go up. Okay, so those are how you work problems 1 through 4. Just refer to your end behavior chart. Look at your exponent, even or odd, then the term, positive or negative. Okay, now the next several problems are talking about the zeros of polynomial functions. Okay, zeros mean solutions. They also mean x-intercepts. Remember, we've talked about this before All those words are interchangeable. Okay, so we're going to talk about how do we find the zeros of polynomial functions. So number 5 is actually going to ask us, it's going to give us a function, then it's going to give us a number, and it's going to say, is this number a zero of this function? Which means if I graphed this function and put it in my y equals and graphed it, would it have an x-intercept at this number? So let's look at how we would check that. Without graphing it. So it gives us the function f of x equals x to the third minus 8x squared plus 12x plus 9. And then it wants us to know, is 3 a zero of this function? Okay, so you could put that in y equals and see if it has an x-intercept at 3. And if it does, then yes, it is a zero of the function. But sometimes, you know, it's real hard to see on the graph whether or not it's crossing at a certain number. So this one says to use substitution to see if this one is a zero, which just means replace the x's in the function with this 3. And if it gives you 0, then yes, it is an x-intercept. So let's replace the x's with 3's, which means I'll have 3 to the third minus 8 times 3 squared plus 12 times 3 plus 9. And then do this math. So let's do our exponents first. 3 to the third power. That doesn't mean 3 times 3. It means 3 times itself 3 times, which gives me 27. I have to do this exponent before I can do the multiplication, right? You have to follow your order of operations. So this 3 squared turns into 9. So I have minus 8 times 9, and then I'll just bring this all down. You could do it if you wanted. So that way, now my next step in the order of operations is multiplication. So I'll do all my multiplication on this step, which is here and here. So let's see, I've got 27 minus 72 plus 36 plus 9, and then I would probably just punch that in my calculator so I don't try to do that in my head. 27 minus 72 plus 36 plus 9 in your calculator does equal 0, which means is 3 a zero of the function? Yes. If it's not, it gives you something other than 0 there. Any other number would mean no. Okay, now the next several problems are going to give us a function and ask us to find the zeros, and it's going to question about its multiplicity. So I'm going to write some notes up here to explain that. Oh. Good. We can write that down. Okay, so to find the zeros, and zeros are the x-intercepts of the function, you're going to set the factors equal to 0 and then solve those for x. Okay, now what the multiplicity tells you is for each particular 0, there is two kinds of x-intercepts. There are x-intercepts There are two kinds of x-intercepts, okay? There's x-intercept. If you touch the x-axis, you are an x-intercept, which means you can either, there's this kind, that means it touches it, but it doesn't cross it. It touches it and then goes back the other direction. Or there is this kind, which actually crosses all the way through it. So those are the two different kinds of x-intercepts that you see. Okay, what makes that happen is called its multiplicity. The multiplicity comes from the exponents of the factors. When we get into this, you'll see where all this is placed. If the exponent is even, it has even multiplicity, which means it's tangent to the x-axis. What this word means is this kind of x-intercept. It touches the x-axis and goes the other way. So that's what tangent to the x-axis means. If the exponent is odd for that factor, then it has odd multiplicity, and it's this kind of x-intercept. It's the kind that passes through. So here's what that would look like. So let's say I had a function that looked like this, okay? It's just missing the f of x. These are your factors, the two things that are multiplied together. Those are your factors. If I was going to find the x-intercepts of this particular function, I would set each of the factors equal to 0 and solve them for x. So I'd have to subtract 7s here. That would give me x equals -7. If I'm going to solve this one for x, I would have to get rid of that -5 with a +5. So I will be left with x equals 5. So 5 and -7, if you put this in your y equals and graphed it, there would be x-intercepts at -7 and +5. That's how you find the x-intercepts of the graph. You get its factors, which a lot of times are what's in the parentheses. set them equal to 0, and solve them for x. Now, the second part of a lot of these problems are going to say, what is the multiplicity? Well, the multiplicity comes from the exponents of the factors. So in other words, this x-intercept has an even multiplicity because the exponent of the factor that it came from was 6, which is an even number, which means this x-intercept, when it comes to -7 on the x-axis, it's going to be tangent there. It's just going to come to the -7 on the x, touch it, and go the other way. This 0 at +5, its multiplicity is 3, which is an odd multiplicity, which means this x-intercept, when it comes to +5 on the x-axis, since its multiplicity was odd, it's going to cross all the way through the x-axis. It's that kind of x-intercept. Okay? So, let's look at some of these. Like number 6. Now, unfortunately, sometimes the function that's given to you is not going to have the factors all nice and neat out for you. You're going to have to do the factoring on your own. So you can see the factors to set them to 0. Like number 6, the function is f of x equals x squared minus 4 to the 4th power. Okay, so inside here is not all the way factored, right? It's not factored. If you're factored, then your x doesn't have a squared anymore. It'll just be an x plus or minus something. Okay, which means I have to do the factoring on my own, and I have to remember what kind of factoring this is. It is an x squared. So you could use your quad program, right? You can solve anything for x if it's squared in your quad program, okay? But I'm going to write this one out so you can see its factors. This is a difference of perfect squares. So when I factor it, I need x and x for x squared. How are you going to get the 4? You got to use the same number twice to make it a difference of perfect squares. So let's see, I'll use 2 and 2. When you're factoring a difference of perfect squares, your signs are always one positive, one negative. Doesn't even matter which way they go. Now, this, so all of this in here is to the 4th power. So even when I write it out in its factored form, they are still both to the 4th power. Right? That's what this parenthesis means. Whatever's in here, whether it's not factored or whether it is factored, is all to the 4th power. So now we can set our factors equal to 0. So x plus 2 equals 0 and x minus 2 equals 0. Solve them for x. So subtract 2's here. So x equals -2, so there's one of the x-intercepts. Add 2's to this side, so x equals +2. There's your other x-intercept. So the x-intercepts, or the zeros, are -2 and +2, and the multiplicity of both of them. So what's the multiplicity? It's just whatever the exponents are on the factors. So both of their multiplicities are 4. So set the factors equal to 0. Solve them for x. That gets your x-intercepts. And then the multiplicity is just whatever the exponents were on the factors. All right, number 7. Again, you can tell whether or not it's factored. If what's in parentheses has an exponent on the x, that means you need to do some factoring. But look at number 7. X to the 5th, x minus 2 squared, and x plus 9. Look at all those parentheses. Is anything inside these parentheses have an exponent? They don't. They're just x's. That's what you want to see because that means it's factored. I don't have to do any factoring. I can jump straight to the step where I set my factors equal to 0. Every factor that has an x sets equal to 0, which means this factor, remember, this doesn't have anything to do with this step. This is its multiplicity number. Here's the factor. I set it equal to 0. Here's my factor. So x minus 2 equal to 0 and x plus 9 equal to 0. This one's already solved. So there's one of your x-intercepts. It's going to have an x-intercept at 0. This one I need to add the 2 to both sides. So x equals 2. And here I need to subtract the 9 from both sides. So x equals -9. So there's your x-intercepts, or your zeros. And it asks it in a weird way. It says, what's the smallest 0? Then the middle 0, or whatever it says. Yeah, middle 0. And then the largest 0. So in other words, these are your zeros, -9, 2, and 0. So the smallest 0 would be -9. And then it's going to ask for its multiplicity. So where does its multiplicity come from? Well, I'll come back and look at the factor that I got it from, which is this one. And look at its exponent. If you don't see an exponent, it's an automatic to the first power, right? So its multiplicity is 1. So the middle 0, so that's the smallest. That one's bigger than this. So here's your middle 0. So your middle 0 is 0. And its multiplicity, let's see, that came from this factor. So its multiplicity is 5. And the largest 0. So 2 is my largest 0. And its multiplicity was its exponent, which is 2. Right? Number 8. Number 8's another one like this. See, f of x equals -7, then x minus 4 to the third power, x plus 2 to the fourth, and x to the second. So I need to find its zeros. This is a factor, but it doesn't have an x with it, right? You can't set this equal to 0 and solve it for x if it doesn't have an x. So this doesn't make an x-intercept. You only make an x-intercept if you're a factor with an x. So here's one. I need to set it equal to 0. Here's another one. Set it equal to 0. And then my last one is just the x, and I'll set it equal to 0. So there's all your factors, set equal to 0. Let's solve them for x. So add 4s to that one. So that x-intercept is 4. Plus 2, so I need to subtract 2 to get rid of that. So x equals equals -2. So there's that one, x-intercept. And this one's already solved, right? It's just x equals 0. So there's your 3 zeros. Here's how to ask you this one. So it says the 0, 4 has multiplicity blank. Well, here's my 0, that's 4. So I just go back up and I'll look at its factor and its exponent. So its multiplicity was 3. Right, the next part says blank is a 0 of multiplicity 4. So what tells you the multiplicity? The exponents. So there's my multiplicity of 4. What did its 0 end up being? -2. So -2 is the one that has a multiplicity of 4. And then the last one says the remaining 0 is blank. With multiplicity blank. Oops. So let's see, which ones have I already done? The 0, 4, so I've already done this one. -2, so I've already done that one. So the remaining 0 is this one. So the remaining 0 is 0. And when I come back up here, what was its multiplicity? 2. Okay, the next 2 problems are the ones that'll take a little bit of work. They're not going to be all nice and neat with the factors already showing. You're going to have to do the factoring, and it's an uncommon type of factoring on both of these. It's called factoring by grouping, which is what you use when you have a polynomial function that's got 4 terms, but there's nothing in common with those 4 terms. So let's see how to do that. So let's see, number 9 says f of x equals x to the 3rd minus 7x squared minus x plus 7. So, like I said, there's 4 terms in this function, and there's nothing in common with all 4 of those terms. So I can't pull anything out because there's not a greatest common factor with all 4 of them. So what I'm going to do, why this is called factoring 4 terms polynomials by grouping, is because that's your first step. You're going to put the first 2 in a group and the second 2 in a group. Then you're going to pull out the greatest common factor from each of the smaller groups. So looking in this first group, I've got x to the 3rd minus 7x squared. You want to take out as much x as you can as the greatest common factor. So they actually both have x squared that you can pull out. And then put in parentheses what is left. How do you find out what is left? Well, whatever you pulled out, that's what you divide both of those terms by to put in parentheses what's left. So I divide both of these by x squared. So let's see, if I pull an x squared out of x cubed, I'm just left with an x minus, if I took the x squared out of this term, what's the only part of it that's left? That's 7. So I'm done with the first group. I'm going to do the same thing in the next group, but I run into a stumbling block because when I'm looking at this group, I don't see anything in common. But there's actually two numbers that everybody has in common. There's two numbers I can divide anything by, +1 and -1. So here's how you decide what you're going to pull out, because you have to pull something out. You want what's left in your second parentheses to be exactly the same as what's left in your first parentheses. So here's what I have. So you can kind of just check it with the first term. This first term is a -x, and I need it to be a +x, which means I need to change the sign. What changes signs? Dividing by +1 or -1? Dividing by -1. So that's why I'm going to pull a -1 out of this second group, which means that's what I divide by. So if I'm dividing by -1 here, it's just going to change that sign to +x, and it's going to change this sign to -7. So you'll notice that those are going to be the same. They have to be. So now we're to the point where this is what's in common. So it's kind of like now you can pull that x -7 out. That's one of the factors. Your other factor is the two terms that you had pulled out. So it's x² -1. And we're halfway there. I can't do anything else with this factor because its exponent is 1. If you have a parenthesis and your x is still squared, that means you got to keep going. You don't have an x factor. So here, this is a difference of squares. I can factor that as a difference of squares, right? That's a perfect square. And 1 is also a perfect square because what's its square root? 1. So I can factor this difference of perfect squares, x and x for x squared. 1 and 1 for 1. Remember, when you're factoring difference of squares, you always have a plus and a minus. It doesn't matter which order. Okay? Now, you're completely factored, right? None of the x's inside of those parentheses have exponents, which means these are your factors that you set equal to 0. And solve them for x to get your 3 x-intercepts. So let's see, on this one, I'd have to get rid of your -7 with a +7. So x equals 7. Get rid of your +1 with a -1. So x equals -1. And get rid of this -1 with a +1. So x equals +1. So there's your 3 zeros. 7, -1, and +1. And the second part of it asks each 0 has multiplicity blank. Well, where did these come from? These factors. What is the exponent of these all these factors? They're all 1s. Okay? So all their multiplicity was a 1. Okay? Number 10 is just like this one. So if that one was confusing, we're about to see another example. So hopefully, now that you've seen it once, hopefully it'll be a little better. Okay. Number 10, f of x equals 7x to the third minus x squared minus 112x plus 16. Again, 4 terms, nothing's in common with all 4 of them. So I'm going to put them in smaller groups. And pull out what's in common with the smaller groups. So let's see, this one, again, they have x squared in common. So if I divided them both by x squared to put in parentheses, what is left? Let's see, if I took x squared out of this term, I still have the 7 and I would still have one of the x's. Minus, I took out everything. That's not a 0. What is something when you divide it by itself? Because that's what you're doing, is dividing. So that's 1. So let's think about this. Remember, you want what's left over in this parentheses to be the same exact thing that's left over in this one, which means somehow negative 112 has got to turn to 7. So what you can do is divide that. See if it divides by 7. It does, which means, look, that means that 16 is going to go into both of these. Now I need to decide, am I going to pull out a 16, positive or negative? So in other words, does this x term need to change signs to be like this one? Well, it's negative, and we need it to be positive. That means you need to change signs. That's telling you to pull out a negative. So let's see. When I divide negative 112 by negative 16, it gives me positive 7x. Positive 16 divided by negative 16 is negative 1. These match, so that's one of the factors. Your other factor is what you pulled out, which is x squared minus 16, which means this one's not done. And just like the last one, those are both perfect squares. So this one's good. This one needs to factor again. Since its x is still squared, I'll use x and x. To get to 16, I will use positive and negative 4s. So there's my factors. Everybody's just an x, so let's set them equal to 0. And solve them for x. So this one, to solve this one for x, I need to get rid of that minus 1 with a plus 1. So 7x equals positive 1. Divide by 7. So that would just be x equals 1/7. So there's one of your x, or there's one of your zeros. This plus 4 I need to get rid of with a minus 4. So x equals negative 4. So there's another 0. And the minus 4 I need to get rid of with a plus 4. So x equals positive 4. So there's your 3 zeros. 1/7, negative 4, and positive 4. And once again, what's the multiplicity of each? Well, they came from these 3 factors. So all their multiplicity is 1. Okay. 11 and 12 are both going to give you a statement that's got a function, and it's asking about multiplicity. And it's asking if the statement is true or false. So number 11, the function is p of x equals x minus 4 squared, x plus 6 to the 5th, and it says crosses the x-axis, which means it has an x-intercept at 4, 0. So crosses x-axis at 4, 0. So we want to know if this is true or false. So let's see, what factor would this have come from? If the x-intercept is 4, that means it came from this one, right? Because if you set that equal to 0 and solved it, you would say x equals 4, which is an x-intercept of 4, 0. Now, here's the word. It crosses at that x-intercept. But look, what is this one's multiplicity? It's even, right? Which means, yes, it is an x-intercept, but what does even multiplicity mean? Even multiplicity means it's tangent to the x-axis at 4, 0. So it would be false. It doesn't cross the x-axis at 4, 0 because the even multiplicity makes it be tangent to the x-axis at 4, 0. All right, last one is another one just like this. So this one says this function would be tangent to x-axis at -3, 0. So which factor would this have come from? This one or this one? It'd come from this one, right? Because if this is the factor and you set it equal to 0 and solved it for x, you would get x equals -3, which makes this x-intercept. So now we just need to check the multiplicity to see if tangent is the right word. So let's see, it came from this factor, which means its exponent's even, which does mean exponent even means it has even multiplicity, which means yes, it is tangent. So yes, that is the right word. This one would be tangent to the x-axis at -3. Okay? All right, so Sunday, what is due is review for test 2, then the actual test 2, and then section 8.1. So those 3 assignments are due Sunday at midnight. I have got Devin, Maggie, Abby, Paul, Alton Jarrell, Gabriella, Tabitha, and Jason. Okay. All right. If y'all don't have any questions, I will see y'all on Monday and have a great weekend.